Hello and welcome back. In the last video, I covered my solution to the Subtiles 2 puzzle of Jane Street. Now I thought that since that puzzle was based off the 2018 puzzle, why don't I go over how to solve that as well? I'm going to be seeing if I can use my solution to the Subtiles 2 puzzle to solve the original puzzle. When we look at what we have to do, we can see that it's nearly identical to the Subtiles 2 puzzle. Instead of having to solve for some variables, we're given the integers at the start itself. The only reason I can't go ahead and apply my solution from the previous puzzle is because the integers 4 and 7 are missing from the board. This is an issue because in our method to generate all possible k ominoes, we rely on a list that keeps track of all locations of a given integer k. And now, we don't have any locations for 4 and 7. When we look at the method that requires this list, overlay shape, we can see that what we do is we fix a position representing the location of an integer k on the board, and we go through every block in our k-omino to overlay the k-omino onto that position on the board. Now, since we don't have any integer on the board, what we're going to be doing instead is anchoring down our k-omino and choosing one fixed point. Then, we can imagine moving the entire board around this one point. We overlay every empty square of the grid onto this fixed point on the k-omino and then check if the k-omino fits. As you can see in this modified method, we fix a point on the k-omino and we iterate through every free block on the grid, which is represented by the locations of the number 0 on the grid. And that's it. The method will successfully return true if our shape can fit anywhere on the grid. We can now incorporate this method into our k-omino generator. The last thing we have to do is rewrite the other method that requires this list, which is a method that actually puts the shape onto a grid. Doing this is very simple, as all we have to do is incorporate the logic we just described. We fix a point on the k-omino and go through every free block on the grid. If we find a block on the grid that allows for our k-omino to fit when we overlay the k-omino's point onto it, we can then add the shape onto the grid. Now all we have to do is incorporate this method into our recursive method like this. When we click run, we can see that this method finds a solution in under a second. The last step to do is to multiply the areas of the empty spaces, being 4 times 4 times 4 times 2 times 2, which is 256, which is indeed the right answer. If you have any questions, let me know in the comment section down below. Otherwise, goodbye.